Hey, what's poppin'? In this video, we're going to be looking at how do we calculate the determinant of a 2 by 2 matrix? How do we calculate the inverse of a 2 by 2 matrix? Before we begin, I would just want to say that these concepts, determinants, inverses, do extend to higher order matrices. 3 by 3, 4 by 4, 5 by 5, you get the idea. However, when we start getting into 3 by 3 and beyond, the computations for doing inverses and determinants gets kind of messy. This is just intended to be an introduction. We're going to keep things as simple as we can possibly keep them, and we're only going to focus on 2 by 2 matrices in this video. With that said, let's get right to it. To begin, we are going to calculate some determinants. But before we do that, let me just refresh your memory and point out that if we have a square matrix that's 2 by 2, the determinant of this matrix is given by this formula. AD minus BC. Because the determinant, the formula has subtraction, and the order makes a difference. You always want to start in the upper left, shoot down to the lower right, and then subtract from that upper right, shoot down to the lower left. Let's illustrate this with an example, and the directions are going to be calculate the determinant. Okay, I am standing on my tippy toes trying to write that. I'm sorry if it's a little bit sloppy. All right, so let's do it. Suppose we're given this matrix, -4, -5 in the first column, -1, -4 in the second column. We're asked to find the determinant. We're just going to apply the formula that has been handed to us, and you don't need to memorize the formula. I'll provide it to you on any type of assessment, but you'll probably use it so much that you'll end up memorizing the formula just from using it. So what do I need to multiply first? First, I need to multiply upper left number by lower right number. The first part of my determinant is going to be -4 times -4. Now, the next part of the formula says to put a minus. Let's do that. Minus, what am I subtracting out now? Now I'm subtracting out the product of that diagonal, -1 and -5. -1 and -5. Now it's just a matter of computing. I'm going to put this in green so it matches up with what's in the matrix. And I'll circle or box this in red so it matches what's inside the matrix. All right, so let's compute this now. This is just kind of going back to when things were really, really nice, maybe, I don't know, 4th grade, 5th grade, 6th grade. I don't know what grade you learn about negatives, but we're just multiplying numbers here. -4 times -4 is 16. Now there's two ways you can approach the back end. You can deal with the negative now, or the subtraction symbol I'm referring to, or you can worry about it after you do the multiplication. Me, I can go either way, but I'm going to do the multiplication first and then worry about this minus sign. -1 times -5 is 5. +5. So now I'm subtracting out something that's positive. I don't need to worry about keep, flip, change, and all that jazz. I can just subtract. 16 minus 5 is 11. That's the value of my matrix. So that's the value of the determinant of my matrix. Sorry, let me be clear. So my final answer is determinant A, in this case, is 11. All right, now, would you kindly do the next example on your own and then check your answer? Here we go. Next example coming your way. Example 2 looks like this. Here's our matrix A, new matrix. We have -3, -4 in the first column, 1, 2. In the second column, please pause the video and have a go with this. Find the determinant. All right, check it out. The value that I got for this determinant was -2. The determinant of this matrix is -2. How did I get that? By taking the difference in diagonal products. -3 times 2 minus 1 times -4. -3 times 2 is -6, right? 1 times -4, -4. Because I have this subtract a negative, what this subtraction symbol really is telling me to do is take the opposite of what comes after it. The opposite of -4 is +4. So now I have -6 plus 4, which gave -2. Hopefully you got the same thing. If you didn't, that's okay. Call me over to your desk. I'll be happy to explain where your mistake may have been if you can't find it yourself. Not a problem. Let's do one more determinant, and then we're going to move on to inverses. Here's our next example. Find the determinant of this matrix. The matrix in question is -2, -4 in the first column, -3, 3 in the second column. Pause that video right now and try it out on your own. All right, check this out. The value that I got for this determinant was -18. Very quickly, the setup, upper left corner to lower right corner, -2 times 3, minus upper right corner to lower left corner, -3 times -4. From there, I just multiply. -2 times 3 is -6. -3 times -4 is +12. With this minus in the middle, just tells me I'm going to do a subtraction problem. -6 minus 12 makes -18. Hopefully you got the same answer. If you didn't, see if you can find your mistake. Can't find your mistake? Call me over for help. Next example, we're going to now get into inverses. Inverses. Right, let's do it. Inverses. All right, so suppose that we're told to find the inverse of this matrix here. So I'm just going to say find inverse. All right, now if the determinant is 0, that's a no-go. Determinant 0 means there's no inverse. If the determinant is not 0, that means there's an inverse to be found. Very important to keep those things in mind from the last video. So the example that we're given, I'm going to start with example 1. I'm going to call it example 1 because we're doing something kind of new now. Let's find the inverse, if it exists, of this matrix, 0, -8, 1, 9. What would our first step be? So in the last video, I provided kind of like a flow chart to help you follow some steps to determine the inverse. What's going to determine if this matrix even has an inverse is the determinant. The first step is to find the determinant, which we just got done doing a couple of examples on that. So that part's really not new, right? So first, let's find determinant. Okay, and I'll even put A. Find determinant A. So I'm not going to be as detailed with the, showing everything here with the circles and the highlighting and all that. I'm just going to do the computation. So I go 0 times 9 minus 1 times -8. And what do we get there? 0 times anything is goose egg. 1 times -8 is -8. And now with these two minuses, that's going to make a plus. So I get that our determinant is 8, right? Determinant is 8. What does that mean? Because I didn't get 0, that means this inverse exists. That means, unfortunately, I have more work to do, right? So just to refresh your memory, hopefully it's in your notes, and I'm only going to be able to write this one time. Space is limited. So if you didn't write it down from the previous video, please make sure to write it down now, because we're going to need it. All right, so if we have a matrix A, what the? Okay, I was confused. I don't know what I did, but I lost my pen. All right, if we have a matrix A, B, C, D, like we have here, and the determinant is not 0, then this right here is the formula that we use to compute our inverse. So what is this formula saying? It's saying that for the inverse, I need to do the determinant as a reciprocal, 1 over the determinant. Okay, that's not hard. I just take 1, stick my determinant in the downstairs. What was my determinant? 8. To get the inside stuff, look at what's happening here. I touched on this in the last video, but let's do a quick review. When I'm computing an inverse, A and D switch spots. They switch positions, they switch location, however you want to think of it. So with this matrix that we've been handed, where 0 is, now 9 is going to be, and where 9 was, now 0 is there, right? So these two switch location. 9 in the upper left pocket, 0 in the lower right pocket. Along this diagonal where we have the 1 and the -8, those two numbers do not change location. Don't you dare move them. But what we will change are their signs. This one now becomes a -1 because it started off positive, and this -8 is now going to be positive because it started off negative. Now, technically, what you have in front of you is a valid answer, but to me, I'm going to say that we need to do a little bit more work, because having this 1/8 on the outside, sorry, another interruption over the PA. What I can do with this 1/8 is I can multiply it by everything inside the matrix. So see, what we're doing there is we're falling back on things that we did last week. We did scalar multiplication. We did how do we multiply two matrices. That's just coming back to haunt us, isn't it? But it's not that hard, right? It's not that complicated. I'm going to take each number inside my matrix. I'm going to multiply it by 1/8. So if you picture each of these numbers inside the matrix as being over 1, so like I said, never enough board space. So like 9 over 1, I'm going to multiply that by 1 over 8. 9 times 1 is 9. 8, or 1 times 8, let me go left to right. 1 times 8 is 8. So the first number in my matrix is 9/8. And that really is pathetic looking. Oh my goodness gracious. I am just not myself today. Having an out-of-body experience or something. 9 over 8. And let's kind of use slashes here because of space. I'm going to do the same thing. 1/8 times 8. 1/8 times 8 would be 8 over 8, which is 1. Okay. 1/8 times -1 is going to be -1/8. And 1/8 times 0 is, well, 0. All right, so there you have it. This right here, let me highlight it in green. This is what I'm going to say is the best answer, and this is what I'm going to expect you to do when you find an inverse. I do not want to see the 1 over determinant thing hanging outside. All right, I do not want that loitering. I want that number pushed through inside the numbers in our inverse, and the reason for that is because eventually you're going to be using the inverse to solve matrix equations. And it's going to be better to push that 1/8 through, or whatever number is on the outside, rather than leave it on the outside. All right, so I'm trying to get you accustomed to that right now. Next example coming your way. I'd like you to pause the video and have a go with it. Here's your next matrix to find the inverse of if it exists. Sorry, that's supposed to be 2. It looks like a GIMP 3. Have a go with this. I have in my first column 1, 7. I have in my second column 2, 9. Hit that pause button. Try it out. All right, check it out. What I got for my A inverse was first column, negative 9 over 5, 7 over 5. Second column, 2/5, that's 2 over 5, and negative 1 over 5. Hopefully you got the same thing. If you didn't, that's okay. This is a learning process. You're going to make mistakes. It's cool. See if you can find where your mistake is. If you can't find it, call me over. Be glad to help. Next example is for you. Here we go. This is going to be our last example, too. Yee-hee! Let's do it. Example 3. Find the inverse if it exists. Here's your new matrix A to play with. We have a 9. We have a negative 9 in the first column. We have a negative 11. We have a positive 11 in our second column. Smash that pause button, try this problem out, and come back, check your answer. See you in a bit. Well, check this out. When I computed the determinant, I got the determinant was 0. Let's just double check that. Maybe I screwed up. 9 times 11 minus negative 11 times negative 9. I think that looks good. Negative 11 times negative 9, 99. 99 minus 99 is 0. Hey, this is kind of good news for us, right? Because now we don't have to compute that stinking inverse. We're done. So what we say at the very end, if we get a determinant of 0, is I'm saying more than I need to say. Here's what I would expect from you. You could just write D and E, and that would be good enough. But I'm being specific as to why it does not exist. Since determinant A equals 0, we got 0, we didn't get something else. That means A inverse does not exist. D and E does not exist. So if you get your determinant to be 0, as shorthand, you could just write D and E, and I'll know what that means. You're saying the inverse doesn't exist, and that's cool. Okay, that's all I have for you in this video. Hopefully this was a good introduction to determinants and inverses. And keep up the good work. Hey, we're getting closer and closer to summer. Not too far away, right? Thanks for watching. Bye-bye.